Let's begin with Amazon Bedrock in AWS Console. You can see in the left pane the various features like foundation models, playground to experiment with large learning models for chat, text, image, guardrails for applying organization policies for input and output, and of course, knowledge base and agents, which we will use to build our customer profile validation assistant. You can see the list of foundation models available to use via a simple API. Let us start with understanding the tables in Aurora PostgreSQL, where the customer profile data is stored. Let us query and see existing profile table for typical e-commerce customer. With the query editor, we can easily access the database and run select and see the columns like name, address, vector embedding stored in profile summary table. We typically will embed the existing data in vector store, Aurora Postgre in this case, to make it searchable. Now let us look at the profile summary embedding was created and stored as a vector. We will use SageMaker's inbuilt JupyterLab environment to write our Python code in the notebook, the summarizer Python code. We will import the dependent libraries mentioned in the code. Then we initiate Boto3 and Bedrock SDK to create the respective clients. The function generateSummary will create a summary of each profile record in the table. This will be used to create an embedding using Claude 3 Sonnet model, which we will have all the profile information and can be extended with purchase info as well in future. The prompt given in summarization is simple. The create embedding function will implement code to create an embedding from the profile summary using Amazon Titan G1 text-to embedding model. Using the Bedrock client invoke model operation, we can create the embedding with specific content type and parameters as required. The insert embed summary creates a connection to Amazon Aurora Postgre database and inserts a record in the profile summary table with the required metadata fields and summary embedding as a vector. Now let's see if the vector embedding happened by doing a similarity search on the HNSW index created on the summary embedding. I have written the same code in a duplicate check Python, which we can use to search for similar records. And now we see Neha Sharma as similarity. Let us see what was in the search criteria. It was finding a profile similar to Sneha Agarwal and a similar location. We can search for more than one similarity or use cosine distance as well. We can improve the prompt and search for to look an exact match or let the agent who will be invoking this function to make that decision. Now that history data is prepared, let's look at the associated documents for identity. We will use knowledge bases to store these documents as embeddings. Let's look at the image knowledge base I have created, which is having customer identity demo S3 bucket and its data store. We see that the two records we have already stored in the knowledge base. Let us look at one record and notice it's a simple Aadhaar card which is used as personal and address identification card in India. We can see the 12-digit Aadhaar number as well. Now that the knowledge base is also set up, let's start building our assistant using Bedrock agents. Let's create a new one, calling it Customer Profile Validation Assistant. Now let's write what the assistant will do, like we discussed before. We can create a service role with the right permissions. I have written the prompt basis the business rule to identify fake profile like email, identity name, address location in India. If more than two rules fail, we will revert, marking it as possible fake and ask user to correct it. Let's paste it in the instruction and save it. We'll add other info later. We can now go ahead and test the agent in the right. Have to press prepare for it to get the latest updates in the agent code. I have written the prompt to save time. Let's start testing with a wrong name and email ID. Let's paste it in the text box and run to test it. You can see the show trace indicates it is executing the logic. Trace gives you insight on how the LLM is using the context information and asking the right follow-up questions. It is rechecking on the first and last name. Let's give a wrong value again. Now it's asking for other missing information like phone and identification number, which I again give wrong. And it identifies it is fake data and politely states it cannot proceed and urges to give the right data. Click on Show Trace to see how the agent evaluated the conditions with profile data. We can enhance it further by having pre- and post-processing trace as well. You can see that the React mode of thinking, it has actually arrived at the right rationale that National Identity Aadhaar number is wrong and wrong format, and the email is also invalid, hence high chance of being fake. Now let's clear the session history and try creating a correct profile with right but partial information. See, it can understand data given in natural language easily and checks if the electricity bill can be considered for identity check. We can check trace again and confirm. And voila, the profile is created when correct data is provided. So how easy was it to build this assistant? With logic given in English language and no coding. Now, let's enhance the agent with existing knowledge base which has identity documents. Let us give the prompt for search in the knowledge base to be accurate. This will help improve the search with specific context. This knowledge base is storing information in Amazon OpenSearch. Now, let's further go and add action groups. Action group for doing complex validations like duplicate profile check and extracting text for uploaded national identity document. Let us write the prompt for duplicate check function. This action will trigger a lambda function. Let's create function 1, check duplicate and its description. The logic is to check if there is similar profile with name and some national identity number and address. We can then enter the parameters that will be passed to the function like profile ID, summary, identity number. This will be used in comparing the values between profile entered and the previously created embedding in Aurora Postgre with summarization Python function. We can also add more data sources to the knowledge base and define the encryption key, chunking strategy, etc. Now, let's switch and see the lambda function that is backing the agent function. There is duplicate check function and you see the code. Inside it is dummy. But the structure is there. So we can go ahead and implement the required logic. Let me show you the profile validation code which I had pre-created to show you all. I have copied the duplicate search code here which does the similarity search. I recommend build and test in local Python notebook like this, similarity search Python notebook. We can test the code in local SageMaker Studio environment and once tested, place it in the respective Lambda function. Like the summarization code, we first create Bedrock client agent and the required parameters like temperature, top P, etc. The detect text function takes the S3 object name and bucket name. See, the prompt is so simple. What is in this image? The Claude 3 Sonnet vision model is very powerful and even with simple prompt can find the information. We can compare with other models by changing the model ID and making it plug and play. Now let's test and see. See how cool that was. With no coding or ML experience, we can read from any image or PDF or document. Now the last part of the demo is UI, built using Streamlit. There are sample code which can be used like the one I'm showing in Bedrock Streamlit Python code, which can be changed to point to the right agent, knowledge base, large learning models, and required prompt to quickly build a chat interface. Pre-built functions can be used to analyze the prompt, upload the document, and build the UI. This brings us to the end of the demo.